Good morning, champions. In today's session, we will try and understand the versatile nature of carbon. Why carbon forms large number of compounds than all the compounds formed by all the elements put together. Carbon forms a variety of compounds. Whatever the things that you almost see around you, plants, animals, telephone, etc., mobile phone, handset, plastic are made up of plastic or semiconductor. So carbon forms a large number of compounds than any other elements, or you can say all the compounds are formed by all the other elements. Carbon forms the basis of life. Just like Lord Krishna present in every living being, similarly carbon is present in every living being. Without carbon we cannot think of life. Without carbon the life of plants and animals, or you can say the existence of life is not possible on earth. So carbon is a very unique element and there must be some strong reason behind it. Earlier it was believed that carbon compounds are synthesized only under the influence of some vital forces, which are present in plants and animals, and we cannot synthesize it in the laboratory. But in 1828, a chemist called Friedrich Wöhler synthesized the first organic compound urea in the laboratory, starting from ammonium cyanide. It forms urea, which is also known as diamine ketone. Since then, millions of compounds are synthesized in the laboratory. With the synthesis of urea in the laboratory, the scientific world start feeling that we can synthesize the organic compounds in the laboratory. Today we are able to synthesize carbohydrate, protein, fats, enzymes, etc. like pepsin, trypsin, etc. And we see them on the chemist shop. And today we are buying them, right? So with the synthesis of urea, large number of compounds were synthesized in the laboratory that we study them in organic chemistry. Organic compounds are the compounds which are obtained from the plants and animals, that is from living world. But today the definition has got changed. We say that the compounds are hydrocarbons and their derivatives. It means the compounds of hydrocarbons and those compounds which are derived from the हाइड्रोकार्बन्स हाइड्रोकार्बन्स और उनसे प्राप्त कंपाउंड्स को हम ऑर्गेनिक कंपाउंड्स कहते हैं. So इतने सारे कंपाउंड्स बनाने के पीछे कुछ स्ट्रॉन्ग रीजन तो जरूर होगा. So in this session we will try to understand the reasons behind the versatile nature of carbon. Why carbon forms large number of compounds. The first reason behind the versatile nature of carbon. Why carbon form large number of compounds than any other elements. As per NCERT, about 3 million compounds of carbon are known, and it is believed that every day new organic compounds are synthesized in the laboratory. So there must be some strong reason behind it. Reasons behind versatile nature of carbon. But before we understand the reason behind the versatility of carbon, try to understand what do you mean by this versatile word. Versatile means, take an example of any actor. That uh, actor X can perform as a child, as the father of child, as well as the grandfather of child, and he can also performed as you can say the girlfriend of the boy, isn't it? So, as a versatile actor suits itself in different roles, similarly, carbon suits itself in different roles. That's why carbon is very versatile in nature. So, the first reason behind the versatile nature of carbon is a property that is called catenation. We are now understanding the reasons behind the versatile nature of carbon. The first reason and the strongest reason, catenation. The tendency of an element to form self-linkage chain of its atoms and gives rise to a large molecule is called catenation. So catenation is defined as the tendency to form self-linked chain of its atom. The tendency of any element, right, which forms the chain of self-linkage atoms to give rise a large molecule, this is called catenation. Suppose 10 or 12 atoms of carbon are joined together, right? It forms a chain of carbon atoms. But this tendency of carbon to form carbon-carbon atom chain, right, by self-linkage is called catenation. So catenation is one of the reasons behind the versatile nature of carbon. Carbon exhibit the phenomenon of catenation and forms chain of self-linked carbon atoms. It shows catenation in different way. So carbon exhibit the phenomena of catenation, right? It means carbon has tendency to form chain of carbon atoms, right? So carbon shows the phenomena of catenation and forms chain of self-linked carbon atoms. It shows catenation in different ways. It not only exhibit the phenomena of catenation, but also shows catenation in different ways. It means it can form different types of chain of carbon atoms. Besides carbon, there are other elements such as silicon also exhibit the phenomena of, right, catenation, but not up to the extent carbon does. Silicon form catenation up to 7 8 elements. Above that number of elements, silicon molecules become very unstable, or you can say very reactive. That's why no other element, no other elements form catenation up to the extent carbon does. Silicon exhibits the catenation up to 7 or 8 atoms, which is very unstable. So no other element can form catenation up to the extent carbon does. You will understand how carbon forms catenation by taking some examples. Now we understand that carbon shows catenation. It means carbon forms chain of atoms of carbon linked together, right? So we will try to see what kind of chain is formed, what types of chain of carbon atoms is formed by the carbon. So carbon forms open chain as well as branch chain. Open chain and closed chain. In open chain, carbon forms a straight chain as well as branched chain of carbon atoms. This is a straight chain and this is a branched chain. This one is closed chain. There is also closed chain. So the carbon not only forms chain of carbon atoms, but it forms the chain of carbon atoms in different ways. It can form a straight chain of carbon atoms, branched, as well as cyclic, or you can say closed. So in this way you can say that carbon exhibit different types of catenation that makes this element a unique and versatile in nature. So it is if somebody asks you to tell the strongest reason for the versatile nature of carbon, catenation is one of the most strongest reason why carbon forms large number of compound, right? So you can understand that carbon forms the linkage of carbon atoms in different ways, in a straight manner, in branched chain, as well as in closed, or you can say cyclic chain, right? And this is the reason why, and these add up to the carbon's property to form large number of compound, right? Now we will understand the second reason. Now The second reason behind the versatile nature of carbon is isomerism. We have just seen that carbon has tendency to form different types of chain of carbon atoms, right? That property add up to a new phenomenon that is called isomerism. So the phenomenon in which certain compound having same molecular formula exist in more than one structural form is called isomerism. And different forms are called structural isomers. So, carbon has another unique property that is called isomerism. It exhibits a phenomenon of isomerism. And what is isomerism? The phenomenon in which certain compounds having same molecular formula exist in more than one structural form is called isomerism, and the different forms are called structural isomers. Right. So carbon exhibit the phenomena of isomerism. Carbon and due to which it forms large number of compounds. Although the molecular formula remains the same, but because of the different structures, right, the characteristic property of the compound get changed, right? So it is one of the strong reason behind the formation of large number of compounds by the carbon. Let us see some examples of different isomers of carbon compound. So first example, carbon starts showing isomers from butane. We are seeing the isomers of butane. The molecular formula is C4H10. So butane has two isomers. So it is called N-butane, and the second one is isobutane. The molecular formula remains the same. You can see that 4, 4, 8 and 2, 10, 3, 3, 6 and 4, 10. So the molecular formula is same. Both has the molecular formula C4H10, but the structures are different. So butane has two isomers, right? We will take some more examples of isomers. Now we will take some more examples, right, of isomers. The next example is pentane. The formula is C5H12. So pentane also exhibit the phenomena of isomerism, that is a carbon compound, and it forms three isomers, that is N-pentane, a straight chain, isopentane, and neopentane. So pentane has three structural isomers. We will take one more example of hexane. The molecular formula of hexane. If you check the number of atoms of carbon and hydrogen in these three isomers of pentane, we will find the same number, that is C5H12, right? The molecular formula of all these three isomers of pentane is same, but they exhibit the different structural form. It is one of the strongest reasons why carbon forms large number of compounds. Having the same molecular formula, right, they exist in different structural forms, and because of the different structural forms, they shows different properties. 2,2, that is 2,3-dimethyl butane, and this 2,2-dimethyl butane, and this one is 3-methyl pentane. So in this we see that hexane forms 5 isomers. So we have seen two reasons, that is catenation and isomerism, behind the versatile nature of carbon. The third reason is multiple bond formation. Carbon has a tendency to form multiple bond due to its tetracovalency. We know that the valency of carbon is 4, it means it has 4 electrons in the outermost shell. So carbon is tetracovalent. So it is the tetracovalency of carbon which enables it to form multiple types of bond. Carbon forms single, double, and triple covalent bond between carbon atoms. So it can form single CC bond, double covalent bond, as well as triple covalent bond. And these bonds are very stable, right? So carbon has a tendency to form the multiple bond. Because of this multiple bond formation, the property of carbon compound get changed, and it added to the versatile nature of carbon. Why carbon forms large number of compound? If the bond get changed between the carbon atoms, the entire property of the compound also get changed, right? So carbon has an advantage of forming multiple bond, and because of this multiple bond formation, carbon is very versatile in nature. It helps the carbon to form large number of compounds. Carbon not only forms bond, multiple bond, but it also forms with other elements due to its tetracovalency. The property of carbon compounds get changed when it forms bond with other elements. So carbon not only forms multiple bond, but it also forms bond with the other elements due to its tetracovalency. The properties of carbon compounds get changed when it forms bond with the other elements, right? So just because of the attachment of atoms of new elements or the other elements, the property of carbon compound get changed. Because of this, the carbon forms a large number of compounds. So it is also a reason behind the formation of large number of compounds by the carbon. The fourth reason is atomic size. The atomic size of carbon atoms is comparatively small. This allows the nucleus of carbon atom to hold on shared electrons. Due to a small size, carbon compounds are very stable. Due to a small size of carbon atom, compounds of carbon are very stable. So these are some of the reasons why carbon forms large number of compounds. Let us recap once again the reason behind the versatile nature of carbon. The first reason is catenation, second is isomerism, and third is multiple bond formation. The fourth reason is comparatively small size of the carbon atom, right? So because of these reasons, you can say these are the advantage, right, which gives the carbon the tendency to form large number of compounds, right? So while answering the questions, right, you must keep all these points in focus. Now, what kind of questions could be asked on the versatile nature of carbon? Let us discuss about it. So, based on what we have discussed about the versatile nature of carbon, here are some questions. Questions are: how does catenation help in the versatile nature of carbon? It means how carbon adapts to the versatile nature of carbon. How catenation adapts to the versatile nature of carbon. Because of catenation, carbon is able to form different types of chain of carbon atoms, and due to which it forms large number of compounds. How is the tetracovalency responsible for versatile nature of carbon? Because of tetracovalency, it forms different types of bond, not only between the carbon atoms, but with the other elements also, with the atoms of other elements. This further add up to the versatile nature of carbon, right? Why carbon forms long chain of carbon atoms than any other elements? It forms large number of chain, right? Large molecules, up to 20, 40, 100 carbon atoms linked together. Because of the small atomic size, right? The nucleus of carbon is able to hold the same pair of electrons very strongly. So the small size of atom of carbon adds up to the stability of its compound. So the carbon-carbon bond is very stable. How isomers add up to the versatile nature of carbon? Again, the isomers, we have just discussed that the compounds have the same formula, right? But because of different structure, they exhibit different properties, right? Hence, it also adds up to the versatile nature of carbon. So, go through these questions, right? And try to understand the reason behind the versatile nature of carbon. Thank you.